Okay, now we're going to be looking at the heat equation, and in your review, that's going to be number 3 through 6, I believe. So yes, 3, 4, 5, and 6. So for this equation, we are going to be, or for these problems, we will be using Q equals mc delta T. So Q is going to be our heat, and you're going to see this in calories or joules. M is going to be our mass, and you'll see this in grams. C is specific heat, and the formula that is used is either going to be joules over grams Celsius or calories over grams Celsius. And then delta T is going to be change in temperature, so you'll do final temperature minus initial temperature. So you're going to get problems similar to these. Basically, what you're going to do is just plug in the information that you know. So in this one, it says how much heat in joules is needed to raise the temperature of 355 grams of ethanol, where the specific heat is 2.4 joules per gram Celsius by 63 degrees Celsius. So a couple things. It is asking how much heat in joules. So you're automatically going to be solving for Q. So you're just going to be plugging in the information you know from this formula. They give you the grams, they give you the specific heat. For the temperature, they only give you one temperature. So unless you are solving for temperature, like that is what the question is specifically asking you for, this is what you're going to plug in for your delta T. This means that it was already, the final and the initial was already done, and you were left with 63 degrees Celsius. So let's solve it. Q equals mass, which is 355 grams, times the specific heat, which is 2.4 joules per gram Celsius, times temperature, which is going to be 63 degrees Celsius. Cancel this, cancel this, cancel this, cancel this, until you're left with the unit you want, which is joules. So you're just going to plug that into your calculator. So 355 times 2.4 times 63. That is your answer. 53,676 joules. Okay? Let's move on to the next problem. So, number 4. It says how many kilojoules of heat are required to heat 2,550 grams of water from 17.5 degrees Celsius to 100 degrees Celsius. This problem is also asking for heat, so you will be solving for Q. The only difference between this one and the one we just did is this one wants your answers in kilojoules, so you're going to have to take it a step further. So let's plug in what we know. Q equals mc delta T. Your mass is going to be 2,550 grams. Specific heat. So your specific heat is not given to you here, but remember in your notes we talked about specific heat of water. It's either going to be 1 calorie over gram Celsius or 4.18 joules over grams Celsius. In this case, you're going to be using joules because they want your answer in kilojoules. Okay, so we're plugging it in, 4.18 joules over grams Celsius, and then your change in temperature is going to be final minus initial. So 100 is our final, minus 17.5 degrees Celsius. So 17.5 degrees Celsius. Now plug that into your calculator. 2,550 times 4.18 times 100 minus 17.5. You're going to get 879,367.5 joules. Okay? Now, they want your answer in kilojoules, so you're going to have to convert it. Here you have joules, so you know joules is going to have to be down at the bottom. You want kilojoules, so kilojoules is going to be at the top. Remember, 1 kilojoule will equal 1,000 joules. So you're going to take the number you got, and you're going to divide it by 1,000. So your new answer is going to be 879 we'll say that's 4 kilojoules. Okay? Now let's look at number 5. It says what mass of iron with the specific heat of 0.11 calories per gram Celsius would need 875 calories of energy in order to raise its temperature by 3.5 degrees Celsius. So again, only one temperature was given, so you're going to plug this in for delta T because they're asking for mass, they are not asking for temperature. So we're going to use the same equation, Q equals mc delta T, but we need to rearrange it in order to get mass alone. So mass needs to be by itself. So everything next to it, the specific heat and the temperature, needs to be sent over to the other side. Because they are multiplying, you're going to have to send that over dividing. Okay? So we're going to divide by specific heat and temperature. That cancels. And you got to do it on the other side. Specific heat and temperature. So plug in the information that you know. 875 calories over 0.11 calories per gram Celsius times 3.5 degrees Celsius. Cancel your units, grams, or I'm sorry, calories, Celsius, and then just solve it. 875 over 0.11 times 3.5 is going to be 0.385 grams. 875 divided by 0.385 is going to give you 2,272.7 grams of iron. Okay? Last one that we're going to do like this is going to be number 6, and that says, what is the final temperature of a sample of magnesium with the specific heat of 0.24 calories per gram Celsius if 1,835 calories is added to 612 grams of magnesium at an initial temperature of 19.3 degrees Celsius. So for this one, you have one temperature, but this time the question is specifically asking for the temperature. So remember, delta T equals final minus initial. They gave us the initial. Delta T equals final minus 19.3 degrees Celsius. The question is asking us for this, so we need to solve for this. So we're going to do the exact same thing we did for number 5, but instead of isolating mass and solving for that, we're going to isolate temperature and solve for that. So Q equals mass times specific heat over times delta temperature. So get temperature by itself. Everything next to it is going to be sent over dividing. So you have Q over mass times specific heat. Okay, so our heat is going to be 1835 calories over our mass is 612, and our specific heat is 0.24 calories over grams Celsius. Cancel out the common units. So you're going to do 1,835. No, you're going to do 612 times 0.24, and that's going to give you 146.88. So you're going to divide. So equals 1835 over 14688. 1835 divided by 146.88 is going to give you 12.49 degrees Celsius. So this is our delta T. That is what we just solved for. So we're going to plug this into now this equation. So 12.49 degrees Celsius equals final minus initial. And we said our initial is 19.3 degrees Celsius. We need to get final by itself, so you need to get rid of this and send it to the other side. Because this is subtracting, you're going to do the opposite, so you're going to add 19.3. This will cancel. What you do on one side, you got to do to the other. So plus 19.3. So your total will be 12.49 plus 19.3. So your answer is 31.79 degrees Celsius. Okay, that's it for this portion.